Okay, this video should help you with doing questions 2 and 3 in exercise 2F. So in question 2 in exercise 2F and in question 3, both of these questions are asking you to consider the graphs of a given function. So they either give you some information about the graph or they sketch the graph with some key values given and find what quadratic equation those graphs represent. So let me go through question 2D to begin with. So in this question you have got a graph given and it clearly goes through -1 on the y-axis, goes through, sorry, on the x, -1 on the y-axis, -1 on the x-axis, and through 4. So the roots are -1 and 4. So what this tells me is that my roots must have come from two brackets, one with x plus 1 and one with -4. However, I don't know whether this graph was stretched or not. Okay, so I need to allow for that by maybe saying that it's multiple of this bracket. Okay, so once I got that, I could just expand it. The two bracket will be expanded to x squared minus 3x minus 4. And you can incorporate k or leave it like this, but use the other piece of information that has not been used yet, which means I need to use the fact that the graph goes through x equals 0, y equals -1. I'm giving the y-intercept. So if I sub these values in, I'll have 0 squared minus 3 lots of 0 minus 4. That gives me -1 is equal to -4k. So you could see that k is equal to a quarter. There you go. So if I sub it now into this equation, I'll be getting y equals to a quarter times x squared minus 3x minus 4, which gives me a quarter x squared minus 3/4 of x minus 1. So the value of A is a quarter, of B is -3/4, and of C is -1. So I'll quickly go through question 3 because that's again one question that people got stuck on. So you've got to do exactly the same, but this time you've got the minimum point and it's 5 minus 3. And you still have to find the expanded form of your quadratic, so three-term quadratic, and you are told that it passes through 4 zeros. So this is one of the roots that's given. So if I can actually sketch it a little bit. So it passes through 4 0 and the minimum point is 5 minus 1. So it looks like that maybe. There you go. So you could actually work out the other root and do it the other way by looking at the symmetry. So the other root would have been, this is 1 across, 1 more across by symmetry. That should be 6. But I'm going to show you the same approach as before. So this time, because they give me the minimum value, I know that one of the quadratics that this minimum value could come from is x, if I put it in the completed square form, x minus 5 squared minus 3. But again, I don't know whether it was sketched. There may have been a value in front, so maybe some k. So to find that k, I just need to substitute x equals to 4 and y equals to 0. So it's 0 is equal to k lots of 4 minus 5 all squared minus 3. So that gives me k times 1 minus 3. So k must be equal to 3. So it has been stretched. So y is equal to 3. X minus 5 squared minus 3. Expanding this gives me x squared minus 10x plus 25, and then you've got 3x squared minus 30x plus 75 minus 3, so plus 72. You can check whether I was right with these roots. So if that was indeed 6, your quadratic would have been, let me just do a black pen so you could see it better, some multiple, so let's call it p this time, of x minus 4 and then x minus 6. There you go. So if you expand it, you have p x squared minus 10x plus 24, and we can substitute these coordinates of this point that we are given, the minimum point. So minus 3 is going to be, I could have actually substituted into, I don't know why I expanded it, into this top one, so it'd be easier. So x goes into this, so it's 5 minus 4, and y, yeah, that's right, and then 5 minus 6 goes into this one, so x goes into this side, so that gives me 5 minus 4 is 1, and this one is minus 1, so p is minus 3, so p is 3. Okay, and we did have 3 here, so if I now expand that, multiply this expansion by 3, I'll have 3x squared minus 30x and then plus 72. So that's just another way of doing it, but that involves sketching the graph for yourself. There you go.